Hi, thanks for that. Yeah, thanks for the introduction. I'm Cyrus Facciano, director from XisY, and joining me today is also the other director from XisY, Jared Langguth, who's going to be taking you through our presentation today and the Q&A to follow about how we transformed Ports of Auckland and what we learned in the field. I'll just share my presentation for you. So so today this is what we'll be talking about, and also joining us for Q&A afterwards will be Nick Morton and Salome, who are our team on the ground working with us. So here's our agenda. So first we want to tell you a little bit about who we are as a company, and then we want to also talk to you about something that we've observed around the relationship between business users and data teams. And then after that, we want to introduce a concept that we've come up with called expectation thresholds, which we found to be quite useful in understanding what's going on there. And then also to tell you what we've learned and developed over the years about how to engage the business to ensure that you're meeting their needs and delivering value. And then lastly, Jared's going to bring it home with how we use automation to meet those expectations and deliver value. So who is XisY? Well, we describe ourselves as a management consultancy for the digital age. And what that means is we use contemporary ways of working like design thinking and agile, not only in the way that we deliver, but also in how we help businesses work differently. So how that looks is we work with businesses to understand their goals and their strategy and what it is they're trying to achieve, and give them the means to be able to work towards those goals efficiently and with meaning, so that everyone's unified to a common purpose. And part of that is helping them work with data better. So that involves implementing the right data governance frameworks and processes and policies, as well as how they might manage data better to make it of better quality and more useful to them. And then also we do a lot of work with analytics. So the BI and data science part, we use BI to help business users and business leaders have visibility into the metrics that matter for them. And these metrics represent the progress towards their goals. And we spend a lot of time helping them understand and agree on how they're going to measure and define those metrics. And then when it comes to data science, we tend to take a very business-oriented approach with data science, and that we use data science to test hypotheses to help break some myths about why we think those metrics are changing and what actions would be the most effective. And lastly, obviously, we need to use technology to make all of this happen. And our philosophy is cloud first. It is the 21st century after all. And also we live high in the stack. So that means that if you don't need to build it, then don't build it. So there are very clever companies out there that are doing awesome things with technology and bringing their IP to bear. So leverage it wherever possible. And we do all of these things to help organizations be fit for the future. So when we talk to businesses and when we work with business users, a really clear observation that we've made over the years is that the relationship between business users and data teams is broken. And why we believe that is because of the business user or the customer who receives the analytical output tends to have a very high expectation about the quality of what can be done, as well as the speed in which it can be done. Almost unanimously, everywhere we go, there's a big expectation reset about how long it takes and how complex it is and how difficult it can be to deliver the things that the business needs, and the amount of work that they need to do and we need to do to deliver something that's of good quality. And that generally comes from a very low understanding of these things. To them, it's very simple to get some data, put it in an Excel spreadsheet, make a few pivot tables and maybe some charts, and then they have an answer to a specific question that they're answering. But unfortunately, what that doesn't do is provide a shared understanding of what's going on, nor does it provide an automated, updatable asset that can continue to tell them what's happening without a lot of extra effort. And so this low understanding and this high expectation, in our experience, tends to lead to a low capacity on the data team side, because without an understanding of the capacity and the complexity and what goes into doing it, often these teams can find themselves to be under-resourced. And in doing so, it almost creates this self-fulfilling prophecy, or this tyrannous self-fulfilling prophecy of the data teams being under-resourced because of a lack of understanding, the expectation of the business being high, the understanding being low, and this mismatch between an understanding that is high on the data side but low on the business side, and the data teams tend to be falling further and further and further behind. The business users get more and more upset and disappointed with it and despondent with it, and ultimately end up doing their own thing or hiring their own analysts, and the data and analytics team tends to lose its ability to deliver outputs to the business. So what we've done here is we've tried to represent this visually and describe how things like automation help us meet this threshold. So up the top line here is an example of a typical, we know it doesn't quite work like this neatly, but typically, there's a little bit of engagement up front, understanding what's required, gathering requirements, etc. And then an enormous amount of silo data engineering happens to build a data asset, or build a serving layer, or build a data model that represents all the data that could possibly be needed by the business, which takes forever. And then a very long, convoluted data visualization or data science process that's often done in silos, meanwhile going way beyond the threshold of expectation that the business has. What we have found is that partly through automation, where we are able to automate particularly the data engineering phase, which is where the majority of the work is done, and where the majority of the time is consumed, using automation enables us to engage more often and more meaningfully with the business. So the green squares, where we're engaging at the start, after we've discovered the data, and then continuously through and iteratively through the visualization or the data science phase of the project that we're working on. And in doing so, we don't always hit the thresholds up front, but over time, as the engagement increases and we get more time to engage, the business users' understanding increases, and our understanding and our ability to meet their expectations improves, and we get better and better at delivering those things and more likely to meet the threshold. So today we want to talk to you about a client that we've spent a good long time working with, and have made some significant changes and have managed to supercharge their capability and transform them away from this expectation threshold breach and more in line with their needs. And we want to concentrate into two key areas. So one being Agile BI and how we engage, which I'll be talking about briefly, and then data engineering, which is where the automation comes in, which Jared will cover. So with business engagement, we use Agile BI as a means to engage in a meaningful way, and we start with the goals. So the very first step is get all the business users and business leaders in a room and get them to agree on what their goals are. It sounds simple and it sounds a little bit nonsensical, but you'd be surprised how often this exercise hasn't been done and there isn't a common understanding or consensus around goals. So achieving that is a very good, perfect first step. And then after that, you can then begin to agree on the metrics that you would use or define or design, and then agree on that represent progress towards those goals. And it's very important that you design metrics in the first instance that are observable facts. So things that are lag or observable, factual, that can be measured, rather than getting drawn into leading indicators or drivers, because that's something that we believe is best done with statistical testing through data science. Only then can you agree on how you can make progress from there. And then from there, you can then start to work with the users to understand how, where, and when will you use these measurements. And we've developed the product engineering or the product user story concept into one that supports BI, where we want to understand who's using it, when they would use it, what they're trying to achieve, who's going to be with them, how often they're going to do it, and what the forum looks like. And all of those things give us the ability to design a prototype that we can test and validate that what it is that they're trying to do is indeed achievable. In fact, we even start with a prototype, which is just a digitally sketched representation of a visual metric that the business users can use. And so overall, this is the process that we tend to follow. And this is the example that we use in our reporting that we deliver every sprint, every 2 weeks. And this is, and at ports, we use Ascend to do the data component. So as I mentioned before, the define stage is around business definitions and user stories. Then we do the initial data discovery to understand the data and how it might relate to those user stories, to identify where there might be gaps or quality issues that might get in our way. And then we will do an initial prototype using a product called Figma, which is a design product that's purely just for visualizing, how we might represent these metrics. And then once we test that against the user stories and we get an understanding that we're on the right track, only then do we then start to prototype that using a visualization tool to be able to prototype that with static data. And then we begin to then stream in the live data so that we're able to test updates and things like that. And then from there, we can source the data, streamline it in through Ascend, implement our data quality tests, and then test again. So test against the user stories and validate those metrics with business owners. And oftentimes, particularly in the middle there, which is what the red arrows represent, we find ourselves iterating in that middle phase, quite often until we land exactly where we need to, and we get a clear understanding from the users. So turning over to automation now. So I will hand over to my esteemed colleague, Jared, to take us through automation and how we use that to help meet expectations and deliver value.
Thanks, Cyrus. So our data engineers work in sprint teams, as Cyrus has talked about, and they have a tough task at ports to deliver the information at a rapid pace. The team there requested data to be delivered every 15 minutes on time, every time. And it's a large amount of data to get through, lots of transformations and getting to. So it was super hard for them. So any advantage we can get from automation really helps us deliver at that pace. So our product teams, as I said, they are product teams and not just data engineers by themselves. They have the business in with them. They have business analysts, they have product owners and sprint leads. So we feel it's important to have them as part of the process. So they need to also be able to be contributing to the success and not just the data engineers by themselves. So the Ascend single pane of glass, the user interface, has really helped us strengthen that relationship between the business. We've had business analysts be able to use the on-screen lineage to trace back where a column went missing. So going back through the transformations, found the column, created the bug for the data engineer to work on. So instead of asking the data engineer to do everything, we've brought the business in by using the interface. We've also had the product owner who is responsible for delivering each sprint. They are able to look at the data feeds that come out and verify that that was actually exactly the same as what was described at the start of the sprint. So making sure we're delivering on the value we said we'd deliver on. The data engineers, because we are moving at pace, we have multiple data engineers working on similar things. So that my favorite feature is just the fact that a data engineer who comes along 3 months later to fix a bug is able to visually see everything in the single pane of glass, see the lineage, see the comments, see the relationships, and then make an informed decision of where they're going to fix and what the downstream effects will be. It's such a powerful feature compared to other products where you have to trawl through code to try and hold it in your mind how the relationship works. So that feature alone has really helped us move at pace. So trust for us is huge, much like it is for most people, but we have to maintain our relationship with our business users. Being that as a consultancy, we focus on the business user more than the tech, we need to maintain that trust all the way through. So to keep our risk as low as possible, we put as many business and data checking rules in as possible. So we do the normal nulls, duplicates, the standard things you'll check, but we also add in quite a heavy layer of business rules. And this allows us to make sure we don't shift any previously checked bits of data. So imagine something checked for stats for 2021. The business owner, who isn't technical, has signed off on that. Yes, the data you are showing is exactly the same in the source system. I sign off on that. That should stay static now. We don't want that data to change. So by applying business rules that say in 2021, these values equal these values, they cannot change. So if we do in the future have to change something underneath, which does happen, a join, source table, a recompute or something, we want to make sure that the end product is the same as what was signed off. So as depicted here, we have data quality tests running between the stage and presentation layers, allowing us to have notifications via Slack when something changes from what we decided it should have been. And we use the Great Expectations Python package to do that for us. Some examples on the next slide talk about the tests we've done, or just some examples for us. So we have things like vessel names. That's a ship that comes into the port. It needs to be of a certain naming standard so that we can identify it. So a simple rule, must conform to naming standard. We have a rule where a 20-foot container, so the size of a container, cannot appear to be a big container. So if we're doing statistics or performance metrics on how a container has moved, how quickly it moved, we want to make sure we've got the right size. So again, putting a rule in to make sure that is correct. Vessels, the ships, can only appear to be in a particular part of the port. So again, for performance reasons, we want to make sure we've identified that vessel correctly and that it's in the correct place. Another example there, the last one being accumulation of a day's events. So a vessel has so many events during a day. If we are accumulating those to report for performance reasons, we want to make sure we haven't accidentally added more time than there actually is in a day. So we have a check-in for that as well. So our Ds save time by doing less. So the product is very important for us that it does as much as it can for us on our behalf, so we can spend the time creating queries rather than supporting infrastructure. We also have cost reductions on the infrastructure running faster, especially at ports where we have that restraint of 15 minutes. We have to make sure our complicated transformations are actually completing on time, as well as making sure our data engineers are getting through the work at the pace to be able to deliver each sprint. So two really important things. So some examples, and this first one's just a really simple one. The transformation in Ascend creates an output for you and saves it in storage. So I run a query, it saves it in storage. I don't have to rerun that over and over and over. So if I'm doing something like we did at ports, where we had a complicated amount of data coming in from multiple data sources, the data wasn't as clean as we had liked. There were some complexities in it. So we had to pick it apart, run multiple queries to clean certain parts of the data, and then pull it all together. So to get the speed working of the pipeline, we pulled all the data together in one transform. But to make it, we've made it in small chunks. And these small chunks, each transform, because they saved to storage, allowed us to run it once, get that query correct, and then move on to the next chunk and not have to rerun everything every single time, which saved us in cost of compute, but also the time to get the job done. Looking at partition joins, we've used those a bit. One example is in the productivity of how a person who's a crane operator moves a container from the ship to the shore and around the shore. So we want to make sure that that process is as productive as possible to make sure that containers are moving through the ports at pace. So there are two large data sets there, one that measures the person in the crane. Hey, I've just logged into my crane and working, and I log out, as well as the crane itself having metrics over it, measuring how much it's moving and what it's doing. So those are two quite large data sets. It's a number of people and a number of cranes all working 24 hours. So we want to make sure when we're joining those for purposes of looking at past history or current performance, that we're only joining the data we need, and it's not joining years and years of data. So using the partition joins helped us do that quite efficiently. The comment there about no infrastructure code written, we see many other clients who hand roll or hand write data pipelines. So they're going to a cloud provider, they're writing some code or using the product there and making their pipeline infrastructure. And then it seems like a good idea at the start because you've got exactly what you wanted. It runs exactly how you needed it to run. But then over time, you spend time supporting it, upgrading components, things break, and you have that massive time suck, which is where we don't want to live. We like to live way up the stack as far as we can. So Ascend is great for that. The infrastructure is just running underneath for us so we can concentrate on those queries. And the last comment there is just a way that we have used to save our blowout. So Ascend is great. It can auto scale for you. Love it. We have budgetary constraints about how much we expand. So if I run a complicated query, or one of our guys does, then we want to make sure when they're testing it that it doesn't blow out to run 60 to 100 clusters all at the same time. So we've restricted that to a certain number of ports to make sure that we keep within the budget constraints of the business. Okay, so on our journey, we have had help from more than these 4 people at Ascend, but just wanted to highlight the great effort that the Ascend team puts in. Many occurrences where we have had or asked for support, and they have provided it to us. So some examples are the tips along the way. I won't go through them all, but they have helped us things like optimizing Spark usage or understanding how the Ascend product uses Spark, so we can work within those constraints to be more effective. One of the things I like about Ascend is we can't do too much in it. There's not too many knobs I can twist and change, so I can't get distracted too much. I can concentrate on delivering value. They have helped us with the use of the SDK. So we have a package we run which helps us move our pipelines through the dev, test, and prod CI/CD pipeline. So Ascend helped us understand their SDK, work with it, and produce that pipeline which runs all of our releases. That was great. The also thing they offer is the onboarding. That was helpful, helping onboard us, but also onboard our client, so they can understand how Ascend works as well. And the ongoing Slack conversations back and forth, much appreciated, especially now as we have a solution architect, Adam, who is now local in the Australia-New Zealand region, which is great for us. We usually get forgotten about down here at the bottom of the world, but now we have that more real-time support, which is much appreciated. And then moving on to the steady flow of support. So over the last year, we've been at ports. There have been so many features coming out that have helped us improve our execution time and help keep the product stable. So just to call out a couple here, the SQL parity, when we released parity between Python and SQL, giving us things like partition joins or partition union, that was a much appreciated feature. An example of using that is when we have trucks. The trucks come in and they take the containers that have come off the ships away from the port, so that they have been measured for their performance as well. We had to marry the truck visit time with another table, giving us an ability to measure. Having these partition joins and unions in roughly reduced the time it run by 300%, from millions of rows to thousands of rows. So that really helped us keep that 15-minute timeline that we had to stick to. The cron expressions got added. That was a great feature for us too, giving us much more flexibility of how to kick things off so we can have the upstream things ready before part of the pipeline ran. And the simple feature of SQL querying before a transform and after a transform just gives us a little bit more flexibility. So I like some knob twisting, but it's not too much. Enough to give us what we need, but not enough for the data engineer or even myself to get lost coming up with a crazy solution when really we should be concentrating on the value. And partition watching was helpful too. That's making sure that when the partition changes, only the changed partition data flows downstream. So that reduces our cost and increases our efficiency and reduces our time too for compute. So those are some of the features that we enjoyed in the last year that helped our Ds and that whole team really deliver on that 15-minute promise, which I know I talked about a lot, but for us, that was actually quite an engineering effort. And without the support of Ascend and their engineers, we wouldn't have been able to nail that, giving us the credibility at the client. So that comes towards the end of our chat. We have, I've enjoyed talking about it. It's been a challenging client to get through, but as I said, together we have been able to deliver that with Ascend, which has been great. So I hope you have received some value from the business side and also from the technical side of how we work together as a team at XisY to deliver with the client. And now I'd like to open for some Q&A. Thank you.